So I want to talk a little bit how we get to um, a more, in a certain context, a more useful deployment of how this range function works out. Get it back into kind of XY terminology. So again, this thing that we've already done, but this time, instead of having a plus or a minus h, let's go more general and just add in a change in height, right? My delta h could be plus or minus. So in one sense, it's a little bit simpler to work it out this way. Plus, it also, you'll see the advantage here shortly. So I won't make you go through all of this, but if we were to take a similar path as before, take the tangent of this new triangle that where we do plus a delta h, and we can go through all of this rigmarole, but instead of trying to go for some big, ugly, crazy quadratic, let's just get this in terms of h. And so we go through this thing here, and we come up with this equation down here. The reason why it pays to get it into this form, hopefully you recall that we had one equation that said the final position is initial position plus v naught t ended up being 1/2 at squared. All right. In fact, initially it was this. So I'm just, recall we had done this early on. That's just one expansion of the first zeroth law and the second zeroth law together. And we got average speed out of that when we got the delta t out of that. So we have that parallel running for us here. Only difference is this is all distance. Well, these are all distances too. This term looks a lot like that term because I have a particular value of g. This term don't look anything like that one because there's no speed in it, but it's still a distance. I have a distance plus a distance plus a distance equals a position, all right? So we have this thing here. Problem with it, mathematically speaking, and it's not that it's wrong, but I have 1, 2, 3, 4, 5 different letter labels. Okay, t is truly a variable. I can also change the angle. I can change the height. There's these things that are variable in this equation. R is dependent on those variables, hence the whole range equation idea. So let's move on here. So what we can do is since height is in the y direction, so we're talking about y direction motion. So h and h naught would just be y and y naught, correct? That puts us kind of back into algebra land, xy coordinate axis, et cetera, et cetera. The range was an x-axis length. So instead of having r for range, I could have x, and this puts me back into the Cartesian plane. Everything else is legit. I don't have to transform it into anything else. Well, still has too many variables. So let's get rid of time. So this is the second time that we've taken the cosine relationship and leveraged it for a time variable to get rid of things. So we had this before, and instead of R, we go with X. That gets us, into line with that. And we can plug and chug that into this equation. And so these things lead us from a transformation of H and R in the equation to X and Y in the equation. And once again, we end up with a quadratic. What this means, the usefulness of this, is if we know, say, the speed and the angle of things, we could write a standard function. If we knew the initial speed of something, we knew the angle that it was launched at, and how far it went, we could actually write a function and then use that function to, what's its range at some height. Because this is now a function. This is a function of y in terms of x. Would like to remind you that that's going to be a number. That's going to be a number. You could literally have, y plus 3x minus 12x squared. It could be something like that, conceivably. And we could go through, the other nice thing about this is if I take that equation and when the final y height equals the initial y height, or 0, so that's if it lands at ground level. So really what this is saying, starts and finishes at the same elevation or height. That's all that means. Well, then that term goes away, all right? And you get to here. And if you follow that trail mathematically, well, lo and behold, that's our range equation again. Problem solved. And along the way, we obtain a way to talk about the projectile's path in standard algebraic terms, quite literally, right?